In this video, we want to show that this radical expression here, 1 plus the square root of 13 over 2, is a solution of this logarithmic equation here. So all they're asking us to do is to really just check. That's what you would do if you solved an equation and you wanted to make sure that you got the right answer. You could check it that way. We need to know that if you have a log of some expression, we'll call it x, to base b, and that's equal to the log of some other expression, we'll call it y. And this x could be something like 2x plus 3, and this y could be an expression also involving x, but we just leave it like that. So if we have these two equal, as long as the base is the same, then it has to be true. This will imply that expression x would have to equal to whatever expression y is. So when we check a log equation, just like any equation, we simply plug in the prospective solution, in this case 1 plus radical 13 over 2, into the equation, and that should give us the same thing on both sides. So this side, in this case, I'm just going to work with the x squared plus 3. So I have the log to base 10 is equal to x squared plus 3. The log to base 10 of x plus 6 are equal. So that means x squared plus 3 has to equal 2 x plus 6. So let's plug in the radical expression, the square root of 13, in both sides. And if this is a solution, which is what we're trying to show, we should get the same thing on both sides. So we plug it in there, that's going to be squared, that's plus 3 here. And then we plug it in the right side. So let's square this. It's like the same thing as you're squaring a binomial. A plus b squared, okay, a squared plus ab, 2ab, plus b squared. So if we square the numerator, it's going to be the 1 squared would be 1, plus twice the product of these two terms. 1 times radical 13 is radical 13, and then times 2. And then it's plus the radical squared. Square root of 13 squared just gives me 13. And then we square the denominator. 2 squared will be 4. And over here on this side, let's combine these. Get the same denominator, so let's multiply this by 2 here, and 2 here. So this will give me 12 over 2. And this is 1 plus radical 13 over 2, so let's combine these. 12 and 1 is 13, plus radical 13, and that's over 2. And then over here in this one, we have 1 and 13 is 14, plus 2 square root of 13. And this plus 3 right here, let's put this over 1 here, and then multiply this by 2 and 2. So this will be then plus, actually I want to multiply by 4 here. 4 to get the same denominator of 4 multiplied by 4, so this will be 12 over 4. Now I got everything over the same denominator. So now we do this. 13 and 1 is 14, and then the 12 will give us 26. So this will be 26. And 1, or 13 and 1 is 14, and 14 and 12 is 26. And then the denominator is the same, so we put this over 4. This is the square root of 13. And then we have 26 here and a 2 here. They all have a factor of 2. 4 is 2 times 2, so let's divide through by 2. So 2 into 4 will give me a 2. 2 into 26 will give me a 13. And then 2 into 2 will give me a 1, or just radical 13, so this will be plus radical 13. So I get 13 plus the square root of 13 over 2. And on the other side I get 13 plus radical 13 over 2. And those are the same. So if I were to plug in into the original equation, all I would get is the log of this is equal to the log of this. So that confirms that it's a solution. Now if you were going to solve this equation, you would start this way. you would say okay. Normally you can write the log equation as a single log. If you have it broken down this way, there's nothing added over here on this side or over here, you can just say x squared plus 3 should equal to x plus 6. Bring everything to one side, so this will be x squared minus x. Bring the x over, bring the 6 over, minus 6. 3 and minus 6 is minus 3. We get x squared minus x minus 3 equals to 0. And then you would just solve this quadratic. It doesn't factor, so you would use the quadratic formula, and you would get one of the roots that we introduced here in the video, 1 plus the square root of 13 over 2, and the other root would be 1 minus the square root of 13 over 2. And you could check this second one just like we did this one. So if you want to go ahead and try to solve this one, make this another problem, these are the solutions you should get. 1 plus the square root of 13 over 2 and 1 minus the square root of 13 over 2, and they both will check because they are both solutions. Thanks for watching. We'll see you next time.